So we need to find dy dx, so that means we're going to need to use implicit differentiation. Every time we take a derivative of a term with y in it, we should have a y prime come out at some time. Y prime representing dy dx. So here we need the product rule. The derivative of the first function is 8, so we multiply that by the second function unchanged. And then it's plus the original first function times the derivative of the second function. Now look, this is where a y prime has to happen because the derivative of y with respect to x isn't explicitly known, so we write it as y prime. Okay, the 1/2 power came down and multiplied. The 1/2 power got reduced by 1. And then using the chain rule, the derivative of y with respect to x is y prime. So that's it. That's the derivative of the first one. And then the derivative here, y squared, the 2 comes down. Power gets reduced by 1, so it's a power of 1 now. But then the derivative of the innermost function is y prime. And then over here, the 1/2 comes down. Then the power gets reduced by 1. Okay, and then we could rearrange this equation and solve for y prime. But this question asks us to find the slope at 1, 1. So it's easier probably just to plug in 1 in for x and 1 in for y. That way we can answer the question. So if I plug in 1 in for y in here, I'm going to get 8 for this term. If I plug in 1 in here, this is 8 times 1 to the negative 1/2 is 1. So this is 8 times 1/2. So that's 4y prime. Because 8 times 1 is 8. 8 times 1/2 is 4. 4 times 1 is 4, and then we have a y prime left over. And then we're plugging in 1 in for y, so that's 2y prime. And then we're plugging 1 in for x, so that's 7/2 over here. And then you can solve that equation for y prime, right? Collect like terms. 4y prime minus 2y prime makes 2y prime. And then you can keep going from there. Okay, so for part B, same type of thing, except now we just have an exponential function. So the derivative of 8 with respect to x is 0. The derivative here, we need product rule because we have two different functions multiplying. So the derivative of the first function is y prime with the second function kept the same, plus the first function kept the same times the derivative of the second function. But hold on, we're not done. This is still the derivative of the second function. We need to multiply this by y prime because of the chain rule. Okay. The derivative of e to the y with respect to x is e to the y, it's itself, because that's the derivative of an exponential function, times the derivative of the innermost function using the chain rule. And the derivative of 8x with respect to x is 8, and the derivative of e to the x is e to the x. And same type of thing, you could solve this equation for y prime and then plug in 1, 1, but you're probably making more work for yourself than you need. Just plug in 1, 1 now. E to the 1 is just e, right? It's a constant. Plug in 1 in for y in here, so that's just 1. This is e to the 1 again. And then this is also going to be e to the 1 when we plug in 1. And then we're trying to get y prime by itself, so we can factor out y prime. Oh wait, sorry. It's actually easier. Look, y prime e. This is y prime e, so that's 2 y prime e's. That's easier. And then to get y prime by itself, we can divide 2e from both sides. So the exact answer for this one would be 8 plus e over 2e. That's an e. I don't think, didn't say use a decimal approximation, so it looks like that's it.